Roy set up the following experiment. He poured 200 ml of water into each of the three glass containers, J, K, and L. So that means each of the container J, K, and L contain 200 ml. So that's a constant. Alright, so he placed three containers on a table beside an open window. Beside an open window, that means the amount of wind all three containers receive is the same, so that's a constant. And the amount of temperature each container uh, is subjected to or receives is still the same. That means that is also a constant. So here we have one constant here, and then open window, that means everything else is constant. And then he recorded the amount of water left. Okay, so when you talk about the amount of water left, that means some of the water has evaporated. Now let's revise. What are the factors that affects the rate of evaporation? Okay, we know that what affects is the four factors, but here I'm just going to touch three because humidity is you don't learn humidity in primary school. So factors that affect evaporation: wind speed, we said just now, it's the same. Area of exposed surface, that is what's different here due to the container. But the temperature that all the three uh, containers receive or are at is the same. Let's look at the number two, area of exposed surface. Alright. Now what do we mean by area of exposed surface? Now this is the part where the air touches the water directly. This is what we call the area of exposed surface. So if we compare the area of exposed surface for J, it's definitely much shorter than the area of exposed surface for K. And L is the smallest area of exposed surface compared to J and K. So the higher or the more area of exposed surface of the water to the air is, the more evaporation happens. This makes sense because you can see here that the amount of water that can escape the container is only a little bit, right? Whereas if you compare to this container, there's a whole lot more area or a whole lot more space where the water can evaporate. And of course, K has even a lot more, right? K has a wide area for the water to evaporate, right? So you can see that L would have the least evaporation. So if L has the least evaporation, that means it will have the most amount left. And K will have the most evaporation. So if K has the most evaporation, that means it will have the least amount of water left in the container. Okay, so this is a very basic, very simple question. All you need to know is this here, factors that affect evaporation. Apply this onto the question and you can get the answer. Okay, let's look at the other question. Besides the type of water, at least one other variable that is mentioned above that must be kept constant. Alright, so you know that the amount of water is the same, the type of water is the same, because the question said so. So what then would be uh, other factors that must be kept constant? Actually, there are many factors here that you can mention, but the most important or the most crucial would be the temperature of the water and the thickness of the containers or the type of glass used to make the container. Can you imagine if you pour hot water here and cold water here, then it will of course affect the reading and your experiment will not be a fair test. But so you must ensure that the temperature of the water that's being poured, 200 ml into each of the three glass container, the temperature must remain the same. Likewise, the thickness of the containers, the thickness of the glass must also be the same because that's where heat enters the container. Heat can enter the container from all around, but if it has a thicker glass, then the amount of heat traveling into the water would be affected. So you need to have the same thickness for all three of the containers. Now, how does each using containers made of the same material ensure a fair test? Now, of course, right? If let's say your J is made out of a very poor conductor, whereas K is made up of a very good conductor, then the amount of heat that enters the container will not be a good one, will not be the same, and therefore the experiment will not be a good one, and therefore it will not be a fair test. We know that in any experiment you need to have a fair test. So that's why the material used in all the three containers must be the same to ensure that the same amount of heat is conducted to the water from the surrounding. Okay, to the water from the surrounding. Okay, it is very important. Next, in another experiment, Roy placed the above three containers of water in an enclosed box. So Roy made another experiment. Everything else is the same. It's just that the three will be in an enclosed box. Now, what's the difference between the enclosed box and the open window? Open window, there's more wind. Closed box is not exposed to the sun, and therefore it is of course of lower temperature, right, compared to the open window. It is exposed to the sun, and therefore uh, it is very easy answer for this one. Wait one second. Okay, so what would be the difference between an experiment by the window and an experiment by in an enclosed box? Okay, so more water will be left in each of the containers because the evaporation will be lower. In that enclosed box, the wind speed will be lesser. When the wind speed is lesser, evaporation is lower. In an enclosed box, the temperature can be lower, all right, compared to the open sun. And therefore, when the temperature is lower, the evaporation is lower. So if all the three containers have lower rates of evaporation, that means the amount of water left in each of the containers would be higher. Okay, so this is a very simple question. It just tests whether you know the factors that affect evaporation, and if you just know this and apply it to the question, it can give you full marks. All right, provided that you don't make any careless mistakes. Okay, so with that,